Number 12. So this is the function, rational function, -1 over x plus 4. The graph is given. It will look like this one. 1, 2, 3, 4. So this is -4. So they have the vertical asymptote at net. Okay, so this is the graph. So it asks you from the graph you can find a domain. So the domain is, you can see from the graph, there's a vertical asymptote -4, so x cannot be equal to -4, right? So this would be all real numbers except x equals -4. Okay. If you want to use the interval notation, it would be -infinity to -4 union -4 to positive infinity, right? Y equals negative. So what is the degree for this polynomial? The degree is, what is the degree? Degree is the highest power for the polynomial, right? Degree is the highest power is 4, so this would be 4. So we want to look at the graph for the solution, the graph of the solution for y is less than -3 minus x, and y is greater than or equal to x plus 6. Okay, so the first thing is we need to draw the graph for each one, right? So y is greater than or equal to, so for the first one, so let's look at this line. So we need 2 points to draw a straight line, right? One point is if x equals 0, y equals -3. So this would be 1, 2, 3. So this is this point. If x equals, if y equals 0, x would be -1, right? So -1 is here. This is another point. So you have used the dashed line because here is less than. The equal sign is not included. That means the boundary cannot be included. So which part? The left part or the right part? We just need to test a point. We origin, if the origin is in one of the regions, so then we just test the origin. So we test the 0, 0. How to test it? You just plug in to see if this is true. So 0 less than -3x, -3 times 0 minus 3. So that means 0 is less than -3. No. So you cannot take the region which includes this point. So you should take the other part, which is this part. Okay. So the next one, we use another color. We want to draw the graph for the y equals x plus 6. So we need 2 points. One point is x equals 0, y equals 6, right? Another one is y equals 0, x equals 6, negative 6. Okay, so this is the 1, 2, 3, 4, 5, 6. So this is negative 6 here. And another one, negative 6, 0. 0, 6. So this is the 1, 2, 3, 4, 5, and 6. This is another point. And we should use, because here it's greater than equal to, so this equal sign is included, so we should use a solid line. So this red line divides our graph into two parts, right? Upper half and the lower half plane. So which one should we choose? Then we just pick the point containing this. This is a very special point we often use because it's easy. Okay, so we plug in 0, 0, test the 0, 0. So you have 0. This one should be greater than equal to 0 plus 6. So you get 0 is greater than equal to 6. No, this is not true. That means the region, the half plane containing this point would not be the solution part. So it should be the other part. So what is the common part, right? Because it's a system, so you should satisfy these two inequalities at the same time. So this one would be the common region. This is a dashed line here. This side is solid line, and between. So this would be your solution region. Okay, so the next one. The next one is the graph is given. Right. This is the one graph. And this is another graph. This is 1 and 1. So shaded region is here. So which system? So from the answer, you will see that we must have one is y equals 2x. The other one is, the other boundary is x plus y equals 1. So from the graph, then we should know that this would be the x plus 1, right? X plus y equals 1. So should have a negative. So this one, this dashed line is the x plus y equals 1. So, and this one has a positive slope. So this is the y equals 2x. So this one, the solid line means this equal sign should be included. So the dashed line means the equal sign is not included. So now let's look at some point, right? Some point to test it should be greater than or less than. So here, for this shaded region, it should be below. Let's look at this solid line, right? We just pick a point. For example, we pick this point. This is the 1, 0 point. To see if this 1, 0 is included in this satisfied. So 1, 0. So y equals 0, x equals 1, 2 times 1. So this should be greater than, less than 0, less than 2.1. So you must have y is less than equal to 2x, right? Because if you plug in 1, 0 in this inequality, it will make it to be true, right? So for another one, x plus 1, y equals 1. So equal sign should not be included. So it should be greater than 1 or less than 1, right? So we just test this point. The origin. Okay, so let's look at the origin. 0 plus 0. The other side is 1. So 0 plus 0 equals 0. So it should be less than 1, right? So we know that this point okay, sorry, we don't use 0, 0 point, we use another point. If you use 0, 0 point, of course it will still work, but it will confuse yourself, right? For this region, this is the region for this dashed line, so we pick a point here, for example. In this region, we pick another point, 2, 0 point. So 2, 0 point should satisfy the inequality. So 2 plus 0 and 1 here. So it's 2 should be greater than 1. So that means x plus y should be greater than 1, right? So you have this inequality and this 1. So you put together, it would be y is less than equal to 2x, x plus y is greater than equal to or greater than y, 1. Okay. So you just pick the point on the region, okay, in the region to test. So the next one is you have 3 inequalities. X is less than equal to -4, y is greater than 2, and 3x plus y is less than 6. So the idea is still you draw the graph for each line first. X equals -4. For example, here is 5, he said. So 4 is here, so this would be -4. Okay, so it's less than equal to -4, should be this side, on the left side, right? Y equals 2. Y equals 2 is here, we use another color. Y equals 2 is here, 1, this is the 5, so this is, for example, this is 2. So this would be the dashed line. 2. Greater than 2, so it should be here. Okay, then we have the next one is, we use another color. 3x plus y equals 6. So we need 2 points, right? One point is when y equals 0, x equals 2, and x equals 0, y equals 6. This is 5, this is, for example, this is 6. So this is 0, 6. Okay, and another point is 2. 2, for example, this is 5, so this would be 2. 2, 0. So we connect, so it's less than, sorry, I made a mistake. I should not have the dashed line for the x greater than less than equal to -4. We should use a solid line because this equal sign is included, right? Okay, let's look at the last one. Last one is the less than, so the boundary is not included, so we use the dashed line. So which part, right? Which part? We just plug in, we notice 0, 0 is here. So we use 0, 0. So we plug in 3 times 0 plus y times 0 equals 0. 3 3 times 0 times 0 plus 0 equals 0, right? Which is less than 6. So this side, so this is true. So this point, the half plane containing this point should be included. So this should be the plane. So what is the common parts for these three shaded region? The common parts is, let me draw the graph. Okay, so this would be the common part. This is the boundary. This boundary is not included. And this boundary is included. And this boundary is not included. And this is the common parts, right? Okay. And between it would be the region. This region is unbounded, right? Because you have no unbounded on this side, right? So this is called unbounded region. Okay, so this is the graph. (17) Two types of calculator. Sells two types of calculator. It must sell at least 40 calculators total per week. So at least, you should underline some important words. 40 calculators per week in order to satisfy the distribution requirements. It must sell at least twice as many type 2 as type 1. So at least twice as many of type 2 as type 1. Okay, so if you have X represent the type A, the number of the calculator of type A, and Y is the number of the type B, type 2. Okay. So the first one, at least total should be at least 40. So X plus Y should be greater than or equal to 40, right? So this is the one thing. Another one is at least twice as many of type 2 as type 1. So from this sentence that we know is type 2 is more than type 1, right? So twice. So that means type 2 is at least twice of type 1. So type 2 should be greater than or equal to 2x. Type y should be greater than or equal to L. 2x should be less than or equal to 1. So since this is a real problem, we totally need x is greater than or equal to 0, y is also greater than or equal to 0. So this would be system of inequality to describe this situation. Now we can find the region. Okay? Find the region. So we need to x greater than equal to 0, y greater than equal to 0, so should be this part. First thing is x plus y The next one is 2x equals y equals 2x. Y equals 2x. So when x equals 0, y equals 0. This is 1 point. When x equals 10, y equals 20. This is another point. That's less than equal to. So this is the line. Okay. And here is x. Here is, since this origin is on the plane, on the line, on the boundary, so we cannot use the origin, right? We just pick arbitrary point. We pick this point, for example. This is the 10, 0 point. 10, 0 point. Okay, we test the 10, 0 point. So 2 times 10 is should be less than equal to 0. No. So this region, the region below this, we use another color. So the region below this line, the blue line, should not be included, so which it means, which is above this line, right? So both greater than equal to 0, x and y greater than should be here. So this would be your answer. Use the purple one. So this purple line means the extended